Okay, well, a- as it suggests, I'm Stephan Faulkner, and I'm telling you a politically feasible way that I think would work to colonize space with the current types of Congresses we see. This won't so much go into legal law, but more of a method on how to do it. Now, uh, why should we colonize space? Being the first question, is it's NASA's most important goal, and it reduces the cost of all their other goals, which leads to, okay, but before I get into what the plan's going to be, I'm going to tell you aspects that the plan should incorporate. For example, any plan to try to colonize space needs to identify and develop the needed technologies for colonizations. This includes new technologies that need to be developed and old technologies that simply need to be repackaged in a different system. And once we complete this list, we have space colonization. It's really that easy, nothing more than just a long list. Now, the other aspect is that whatever the plan needs to be, it needs to have a high benefit to cost ratio. Because in the real world, you have a finite amount of money, which means the program with the most benefit uh, uh, gives the most benefit per cost. It conversely means that even if you have a massively beneficial program, if it costs too much, it's useless because it's a low benefit to cost program. And since it's the real world, low benefit to cost programs pull money from high benefit to cost programs. Now, as I was looking at the overall problems NASA's had in the past, not so much the detailed problems, but just the overall from macro view, I see them as unstable budgets between administrations. So whatever the solution needs to be, it needs to be able to handle the ebb and flow of Congress support, because during the life of a program, it will have a Congress that supports it heavily, and it will have a Congress that doesn't really support it much at all. So you need to design a program so that it works in both of these Congresses, not just one. It needs to be managed by someone who can handle things economically, and designed in such a way that no single loss of funding source would kill a program. In addition, another overall problem I see is that NASA is not handing off work, because since they have a finite budget, that means they have a finite number of programs, and you can't start something new until you pass off the original program and it's no longer on NASA's budget. Imagine, for example, if the satellite communication industry, which was $199 billion in 2013, had to remain in NASA's $17 billion budget. You wouldn't get anywhere. The final overall problem I see is designing goals based off the budget. For example, colonization is nothing more than a list of technologies that need to be developed. And so if you do something else because you have a low budget and you want to see short-term results, you're just postponing the list. The list will still be there whether you fund it or not. And even if you have a low budget, you can just work on things, even if it's just slowly, to eventually get to where you want to get to. Now, the solution to this is to use businesses' advantages to cover for NASA's disadvantages and develop all the needed technologies like the Commercial Crew Program. And for those that aren't familiar, it's basically a fixed price contract. You achieve this, you get paid this amount no matter how much it actually costs you. Now, businesses have multiple advantages in that they rely on multiple funding sources. For example, the Dream Chaser program, if that was a NASA program, when Congress pulled funding from it, it would have died and everything that went into it would have been wasted money. But it wasn't a NASA program, it was a business program. So while NASA sped it up, and even though it's lost its funding, it can continue to completion. Another issue is that businesses have a much larger focus on economics. For example, NASA could have made the space shuttle a lot more economical. They weren't given permission to. That would have not happened inside of a business. And this leads to basically better feedback loops for problem solving. Now, the specific advantages NASA would get out of partnering with businesses is a higher effective budget. For example, the SpaceX developed the initial Falcon 9 for $300 million, while NASA quoted it would have costed them $1.4 to $4 billion. If you take NASA's $17 billion budget and multiply it by that money efficiency advantage, you get a budget of $76 to $181 billion effectively. Now, while this, probably not all the money in NASA could be made this efficient, a good portion of it could, which could significantly increase its effective budget. In addition to this, NASA would only have to pay for part of the program. So, for example, if NASA wants to vote with money for technologies to be developed by businesses, it only pays for 1/3 of the cost, and the businesses finds funding from other sources for the rest, and with the goal of getting businesses to establish capabilities for NASA to use. Then this further multiplies NASA's effective budget to $230 billion to $543 billion. Now, if you compare that to the $17 billion they have now, you're accomplishing 30 times more work under the exact same amount of budget. Finally, you can use businesses to shield money from loss from project drops. Oh. Sorry, hold on. You can use companies to hold Congress to a plan. For example, the one moment, slide window. For example, NASA's had trouble keeping Congress to a plan, but if you use, in addition to NASA, Lockheed, Boeing, SpaceX, and Raytheon, Orbital ATK, and basically everyone involved in this long-term contract process to keep Congress to a plan, you'd be a lot more likely to keep Congress to it even during an administration that doesn't support NASA as much. Yeah, in addition, like I was saying earlier, it shields money from being lost from projects being dropped. For example, if you were to able to shield 10% of NASA's funding from being lost from a project being canceled and all funding going into it up to that point being wasted, you'd further multiply NASA's budget by to $256 billion to $603 billion. So the more detailed plan is to use NASA's budget like the commercial crew, pick these programs in such a way that you not only get commercial development in what NASA picks, you get commercial development in what NASA does not pick. And these plans need to be designed from the get-go to be passed off to businesses. They shouldn't be designed to stay in NASA like a lot of programs are. Yeah, I've identified several investment areas that I think would cover this, and that includes commercial small rocket, which is already being done to this day, commercial large rocket, commercial space colonies on the moon and orbit around Earth, space nuclear reactor, commercial vehicles to transfer orbits, commercial spacesuit, commercial vehicles or system to land on the moon, and commercial exploration and utilization of resources. Now, as you may have noticed, I'm basically saying commercial everything, and there's a good reason for that. Because let's say, for example, we were in an alternate universe, and in addition to the current programs we had now, Congress funded a moon base, and we'd been operating it for 10 years. NASA would be saying, we want to do something more. We're going to need more funding for a Mars base if we want to keep the other programs as well. But okay, let's say another alternate universe in which in addition to the current programs, we've had a Mars base and a moon base for 10 years. NASA would still be in a situation in which it needs more funding to do more. Because the main issue is that NASA's budget can't be used for space infrastructure. It has to be used to develop commercial infrastructure so NASA's budget can go on to something new. Because if it gets locked up in space infrastructure, at some point you have so much infrastructure that you get stuck and don't go anywhere. Now, for these investment areas, I've identified requirements I think would lower development time and cost. In the orbital space colony, it should have a zero Moon, Mars, and Earth gravity area. It should grow its own food for some level of self-reliance, and it should be capable of changing its orbit from around Earth to around Mars. This is so that while the initial ones will of course be used around Earth, if someone just decides to have the money, we have a ready-made solution to put a space station around Mars. It doesn't have to be redeveloped, which wastes many years and a lot of money. The commercial lunar space colony would have to be a solution for both Moon and Mars. It would have to grow its own food, meaning it can't use a technique that you can only use on Mars or can only use on the Moon. It has to be usable on both. And it must be able to land on both, which means in the case of the Moon, it should be able in a single stage to land and take off again on the same fuel tank. And in the case of Mars, it would be able to land and then be required being refilled on Mars. But this goes back to one vehicle development time and money, so you don't have to develop two vehicles, which makes things a lot cheaper and takes less time. Then there's the commercial large rocket. It must be reusable or partially reusable to lower its cost and get at least 140 tons into space. Because in the future there will be much larger things that need to be launched just into LEO. The space nuclear reactor, when you start having a colony, you're going to start needing a manufacturing base. Nuclear reactors can use the waste heat for processing ore and the electricity for running the colony. So the initial nuclear reactors should be designed in such a way that they work on an existing or close to existing launch vehicle, like the Falcon 9, Falcon Heavy, Vulcan, Antares. And it's also beneficial to have smaller nuclear reactors, and that a space colony could be ran out of multiple of them, so you could unplug one and plug in another one, and not just have one reactor for the entire colony. And on that, it should be designed in a module and such that it's not part of the colony itself, but off to the side, and last at least 10 years with no maintenance, because they can't be worrying about maintenance of a nuclear reactor up in space, which is actually possible, as there's reactors being developed now that can last 12 years without maintenance. Commercial spacesuit should be able to work out in space or on Moon or Mars, meaning it needs to be flexible enough to work on the ground and have enough protection from micrometeorites in space. And with one spacesuit for everything, you have just one manufacturing chain. You don't have to have multiple manufacturing chains. The lander must work for both Moon and the Mars, so this must be able to land on the Moon and come back on one fuel tank, as I was mentioned earlier, and it needs to be able to just land on Mars and then get refueled. It has to be fully reusable for the reason of that you can't afford fully reusable that deep into space. And it has to have a fuel that can be manufactured on both Moon and the Mars, not just one of them. Any questions? Well, for one example, there's a lot of zero. Okay, the question was, what are the commercial markets to even use these so that the businesses go into them? And some of the earliest markets I see is gravity research for drugs, since and actually, if you look into people trying to do research on the ISS now, there's a huge demand to get into the ISS, but not a lot of supply. And also, once you start having space colonies, there's a lot of government customers from other countries that would be willing to rent out space in those colonies. So there's a pretty good market, and like often the future kind of markets could include things like I could see athletes being trained there under higher than Earth gravity. Yes, yeah, there's also just manufacturing satellites up there in space colonies, so you don't have to launch them from Earth anymore. Any other questions? Well, what it depends on the. Uh, uh, Once you start having drilling on the moon, uh, and they start selling it for money, then there's going to be how can we do this better? So commercials will improve their drilling techniques just as a way to increase their profits, basically, from drilling. So yes, commercial would be developing that. That's one of the reasons for the lunar colony, so that there's off research in drilling. Any other questions? Uh, you would need to develop semiconductors for building satellites into space. So, and you need some level of manufacturing to make solar panels in space. Uh, you'd probably on want people on Earth would probably want some helium-3 for fusion experiments, so I could see them selling that on a regular basis. Or they could even, if they have a well-equipped moon base, set up a fusion experiment on the moon where you're just loaded with your supply of fusion material around you. Uh, I see, yeah, everything in between from Lockheed to small companies. Because, for example, like Lockheed has a lot of specializes in a lot of things, while smaller companies specialize in individual things. And so the smaller companies would work more towards the individual things, and I could see companies like Lockheed and Boeing working more towards. They'd probably be applying for more than one contract because the idea is maybe to have for each of these areas 3 to 5 companies working in them, and I could see Lockheed or Boeing working in multiple areas since their companies works in. His question was in regards to cold fusion, where very cold pieces of metal can be put together and fused together as if they'd been welded. I don't really know anything on that. Any other questions?